Good morning. Good morning, class. Welcome to today's class. You're welcome. So we're going to look at the calculations, the revision on the calculation in physics. Okay, so I gave you assignment during the previous days. So I want to use today to solve all the assignments so that you can be able to compare and contrast if what you solve is actually correct or not. Okay, stay tuned. Let's see who are those that are already online so we can start. Asako Okechukwu, you're welcome. Clifford, you're welcome. Please, can I get notification, please? Tom Frank, you're welcome. How are you today? Tenny Igoma, you're welcome. All right. Please, can you see the two lines on the board? Can we see the two lines on the board? Let me be sure you can see what I'm writing. Asako Okechukwu, you're welcome. Can we see the two lines on the board, please? All right. So we can proceed with our questions. Victoria, you're welcome. How are you today? All right. We are going to start with the first assignment given on density and relative density. Okay, so I'm going to be writing down the questions and we are going to solve it together. Then you compare your answer and see if you're actually what? Correct. Okay. All right, that is the first question. Are we done writing so we can start solving? Secondus, you're welcome. Okay, you're done. Okay. All right, let's look at the question again. An object weighs 10.0 Newton in air and 7.0 Newton in water. What is its weight when immersed in a liquid of density, relative density 1.5? Okay, let's go again. An object weighs 10.0 Newton in air and 7.0 Newton in water. What is its weight when immersed in a liquid of relative density 1.5? Then the first thing we are going to look at is to set our parameters. Okay. The weight in air is 10.0 Newton. The weight in water is 7.0 Newton. Okay. All right. Then the weight in a liquid is what we don't know. Weight in a liquid is what we don't know. But we have relative density to be what? 1.5. Now we should not forget our formula, the formula for our relative density. We have Upthrust. Okay. So we can use that to solve. Let me just write it by saying relative density is equal to what? Upthrust in liquid divided by what? Upthrust in water. Okay. Now, if I go down to solve, you also remember that what is upthrust? Upthrust is the force that acts, the upward force, okay, that acts on anybody that is immersed in a liquid. Now, this body was weighing 10 Newton when it was in air. Now, it was immersed in water. It now weighs 7.0 Newton. Now, we are looking for the weight in a liquid. So, I'm going to use upthrust. Okay? Now, relative density, if we are making respect to the liquid, it's going to be what? Upthrust will be what? Weight in air minus weight in liquid. Then divided by weight in air minus weight in water. Do you understand? If you are making respect to what? The upthrust in liquid, it becomes weight in air minus weight in liquid. But when you are making respect to upthrust in water, it becomes weight in air minus weight in water. Do we understand? So with that being said, let's move in to solve our problem. All right. So we are going to say that my relative density, which is given as 1.5, is equals to, what is my weight in air? I have what? 10, right? 10, right? Okay. Then I will now check. My weight in liquid is what I'm looking for, right? Divided by, what is my weight in air? I also have 10 minus, my weight in water is what? 7.0. So I have 7. Okay. Now, this is the same thing as saying 1.5 is equal to 10 minus weight in liquid divided by what? 3. 10 minus 7 is going to give me what? 3. So I will say cross multiply. If I do cross multiply, this will be over 1, cross multiply, right? So I have 10 minus weight in liquid is equal to what? 1.5 times 3. And when I multiply, I'm going to have 4.5, right? So let's go by saying 10 minus weight in liquid is equal to 4.5. Now, because I'm looking for the weight in liquid, I'm going to take this 10 to the other side to be minus. The sign will change to minus. So this is minus weight in liquid is equal to 4.5 minus what? 10, right? Now, if I subtract, I'm going to have what? Minus 5.5. So this is minus 5.5 Newton. Okay. So this is minus weight in liquid is equal to minus 5.5. So minus cancels what? Minus. Therefore, my weight in liquid is equals to 5.5 Newton. Do we understand? Right. Do you understand what I explained? All right. Please give it a thumbs up, okay? Okay, second is I should explain again. Okay, I'm coming. All right, let me explain. The question says an object weighs 10.0 Newton in air and 7.0 Newton in water. Okay, what is its weight when immersed in a liquid of relative density 1.5? And what are we going to do first? By setting our parameters given. My weight in air is 10.0 Newton. Weight in water is 7.0 Newton. I'm looking for weight in a liquid, and I was given a relative density, okay, as 1.5. So the next thing I'm going to do is to remember Upthrust. That relative density relates what with Upthrust, okay? So what is relative density? Is equals to Upthrust in liquid over Upthrust in what? Water. Now what is Upthrust? Upthrust is that upward force that acts on any object that is totally or partially immersed in a fluid. Okay, so if you are making respect to the liquid, the upthrust will become what? Weight in air minus weight in liquid. Okay, but if you are making respect to water, upthrust will be what? Weight in air minus weight in water. So that is what we have. So we are going to put in our parameters to find the unknown. The relative density is given as what? 1.5 is equals to my weight in air is 10 minus weight in liquid, which is what I'm looking for. Then divided by my weight in air is 10 minus weight in water is 7. Okay, so I bring it down by saying this is 1.5 is equals to 10 minus weight in a liquid. Okay, so by the time I say 10 minus 7 is going to give me 3, right? Then I do cross multiply because I want to get a weight in liquid. That is what I'm looking for. All right, so I will say 10 minus WL is equals to what? 1.5 times 3, right? Which gives rise to what? 4.5. Then I'm carrying this 10 to the other side and the sign will change. Remember here is plus, it will change to what? Minus. So I have minus weight in liquid is equals to 4.5 minus weight. 4.5 minus what? 10, okay? So when I subtract, I'm going to get minus 5.5 Newton, okay? So this negative sign is going to cancel this negative sign. So the weight in the liquid is equals to what? 5.5 Newton. Is that okay? Right. There you go, ma. Grace, you're welcome. Omojo, you're welcome. You said I should repeat Upthrust. I've already repeated this severally, okay? Upthrust is that upward force. Upthrust is that upward force that acts on any body that is partially or totally immersed in a fluid, okay? That is what is said to be an upthrust. An upthrust is a force. Are we done writing? Are we done writing? All right, be fast. Please be fast. Let's proceed. Are we done? All right, let's proceed. Okay, so the next question. "40-meter cube of liquid is mixed with 60 centimeter cube of another liquid cube. All right, this should be 40-meter cube of liquid what? Of liquid P, please. This is liquid P. Is this liquid P? Okay. It's mixed with another liquid. All right, liquid Q. Now, if the density of P and Q are are 1.0 0.00 kilogram per meter cube and 1.6 kilogram per meter cube respectively. Okay, what is the density of the mixture? All right, so copy the question down. Let's solve together. All right, are we done? All right, so let's solve together. Okay, let's solve. Now, this is 40 meter cube of liquid P is mixed with, sorry, this is meter cube. 40 meter cube of liquid P is mixed with 60 meter cube, 60 meter cube of liquid Q. All right. If the density of P and Q are 1.00 kilogram per meter cube and 1.6 kilogram per meter cube respectively, what is the density of the mixture? Now, in this question, they want us to mix liquid P with liquid what? Q. They want us to mix the density of what? Liquid Q with liquid what? Q. So we're going to mix them together. How? Now let's set our parameters by saying volume of P is equals to 40 meter cube. Right? Then we get again of Q, that is liquid Q, is equals to what? 60 meter cube, right? Okay, then density of P is given as what? 1.00 kilogram per meter cube, right? Now density of Q is given as 1.6 kilogram per meter cube. Now what you are going to do now is to get the masses of the two different liquids. We are going to get the mass of P, we are going to get the mass of what? Q. Now, if you are going to use this relationship that density is equals to mass over volume, okay, you should not forget that density is equals to mass divided by what? Volume. So if density is mass divided by volume, now what do we have? We're going to get the mass of this first liquid, liquid P, and also going to get the mass of liquid Q, right? Now what do we say? We say that density of what? P is equals to mass of P divided by what? The volume of P, right? So what you are going to do is to say cross multiply, therefore mass of P is equals to density of P multiplied by what? Volume of P. Do we get it now? All right, so if we have that, What is my mass of P now? What is my density? My density of P is 1.00 multiplied by the volume of P is what? 40. Now when I multiply, I'm going to get the mass of P to be what? 40 kilogram. Do you understand what I just did? All right. Now the same way I'm going to say mass of Q is equals to the density of Q multiplied by what? The volume of Q. That is rho of Q multiplied by volume of what? Q. All right. So let's go ahead to say rho. What's my density? I have 1.6. 1.6 multiplied by the volume is 60. Okay. So when I multiply, I'm going to have 1.6 multiplied by 60. What do we have? I have 96. So the volume is what? The mass is what? 96 what? Kilogram. Okay. Now I've gotten the mass of liquid P and also the mass of liquid what? Q. Okay, so for us to get the density, and density is mass over volume, and you're looking for the density of the mixture. How do you get the density of the mixture? We are going to add these two volumes together, the volume of P and what? Q, because they are now mixture now, and also add the two masses of this mixture, MP and what? MQ together. Then can help us to get the density. Is that okay? All right, put it down. Let's conclude the question. All right. Are we done writing? Are we done writing? Okay, I will explain again. Okay, then you go, man. Let me explain again. I said that they gave us two different liquids. 40 meter cube of liquid P is mixed with 60 meter cube of another liquid Q, right? If the density of P and Q are 1.00 kilogram per meter cube and 1.6 kilogram per meter cube respectively, what is the density of the mixture? Now, how do we do that? What's my volume? My volume of P is what? 40 meter cube. That is this. And my volume of the next liquid, which is Q, is what? 60 meter cube. Now we are giving the density. The density of P is what? 1.00 kilogram per meter cube. And the density of Q is what? 1.6 kilogram per meter cube. Now for us to get the density, one thing must come to our mind. What is density? Density is mass divided by what? Volume. Okay? So if density is mass divided by what? Volume. What do we do next? We are going to say, we are going to compare. This is the density of what? Liquid P is equal to mass of liquid P divided by what? Volume of liquid P, right? But the essence of using this formula is for us to get the mass of the different liquid. Now, what is the mass? I will say cross multiply, right? If I say cross multiply, what do I have? My MP is equal to density of P times mass of P, right? That is what I have. Okay, so I will now put in our values. What is my density of P is 1.00 multiplied by the mass of P is what? 40. Okay, by the time I multiply, I get the mass of P to be 40 kilograms. Is that okay? All right, so I will do the same for that of Q. The mass of Q is equal to density of Q multiplied by what? The volume of Q. My density of Q is 1.6 multiplied by the volume, which is what? 60. By the time you multiply, you're going to get the mass of Q to be 96 kilograms. Is that okay now? Right. Then you go, is that okay now? Do you understand? Okay, so let's conclude the question, okay? Okay, so let's solve. You're going to get the total, the volume of the mixture. The volume of the mixture is what? Vp plus what? Vq, right? My Vp is 40 plus my Vq is what? 60. So the volume of the mixture, or may you say the total volume of the mixture is equal to 40 plus 60 to give me 100 meter cube, right? Then the mass, the total mass, that is mass of mixture, that is MP plus what? MQ. So I have MP to be 40 plus 96. Okay, so when you add, it's going to give me 136 kilograms, right? Now we have gotten the volume of the mixture and the mass of the mixture. Then this will help us to get our density of the mixture, because density is mass divided by what? Volume. All right, so what do? We say that density of the mixture is equal to mass of mixture divided by what? Volume of mixture. Okay, what's my mass? My mass is what? 136 divided by my volume is what? 100. So let's divide 136 divided by 100. What do we have? I have 1.36 kilogram per meter cube. So the density of the mixture is equal to 1.36 kilogram per meter cube. Now let me explain. I've already gotten the individual masses of liquid P and liquid Q, right? Now it now leads me to get my sum total, or the mass of the mixture, right? And the volume of the mixture. So what I did was to add them together. The volume of the mixture is Vp plus Vq, right? That is 40 plus 60. okay, is going to give me 100 centimeter cube. Now I have to get the mass of the mixture, which is mp plus mq, right? I've already obtained that. You get me? This 40 plus 96 what? Kilograms to give me what? 136 kilograms. Now for me to solve for the density of the mixture, that is the mass of the mixture divided by what? The volume of the mixture, and this equals 136 divided by 100. The volume of the density of the mixture gave us what? Gave us 1.36 kilogram per meter cube, okay? And our answer is equal to what? 1.36 kilogram per meter cube. I hope you understand. This is actually a jam question, and if you see this type of question, this is how you are going to solve it, right? This, if you are just coming, give it a thumbs up, okay? And copy fast so we can finish all our assignment today. Are we done? All right, let's solve the next one. All right, so copy this next question. Let's solve together. Are we done? Clifford done, Secondus done, Omojo done, Grace done. Okay, let's solve. A stationary object of mass 4 kilograms is set in motion by a net force of 50 Newton. Okay, if the object attains a speed of 5 meters per second in time, calculate the value of t. Let me go again. A stationary object of mass 4 Newton is set in motion by a net force of 50 Newton. If the object attains a speed of 5 meters per second in time, calculate the value of t. This question is under the linear momentum, okay, and it's precisely under the Newton's second law of motion, okay, which states that the rate of change of momentum is directly proportional to the impressed force and takes place in the direction of that force. Okay, so if you go by that, you are going to state the parameters and let's analyze what you have. A stationary object, you know what is a stationary? An object that is on its own, that is not making any movement, says to be stationary, okay? And when an object is stationary, it's not moving. So its initial velocity of that particular object at that time is said to be equals to 0. Why is it equals to 0? Because the object is not making movement, okay? The object is not making what? Movement. It's a stationary object. And a stationary object, its initial velocity is equals to what? 0. So from that, we say that initial velocity is equals to 0. And the body has a mass of 4 kilograms. So mass is equals to 4 kilograms. Okay? Then it is now set in motion by a net force of 50 Newton. So the force obtained is equals to 50 Newton. Okay? All right. If the object attains a speed of 5 meters per second, this speed is said to be the final velocity because it was at rest before it started making movements, right? Now it was now set in motion and now attains the speed of 5 meters per second. So this speed becomes the final velocity. That is, my v is equals to 5 meters per second. Okay? Calculate the value of what? T. Calculate the value of what? T. How do we calculate the value of t? We are looking for t. That is question mark. So this will lead us to what? The Newton's second law of motion. This says that what? The rate of change of momentum is directly proportional to the impressed force and also take place in direction of that force. So that is mv minus mu is equal to what? Time. Okay. Now what is mv? Final momentum. Why mu is what? Initial momentum. Okay. So what you're looking for is what? Is time. So let's put in our values. What is my force? My force is 50 is equals to, what is my what? What is my mass? My mass is what? 4. Then multiplied by, my final velocity is what? 5. Okay. Then minus, what is my mass? My mass is 4 multiplied by, my initial velocity is what? 0. I've already explained why it is 0, because the object was stationary. It was at its state of rest, okay, before making movements. All right, so you're looking for t. So we go down to solve by saying this is 50 is equals to 4 times that is going to give me 20 minus 4 times 0 is what? 0 divided by what? T. Okay. Now is equals to 50 is equals to 20 over what? T. Right? Then I can make this to be over 1 and do cross multiply to get the value of t. So if I say cross multiply, 50t is equal to what? 20, right? I divide both sides by the coefficient of 50, which is what? T, which is 50. So I have this. I cancel this. So what is my t? This cancel this. I have 2 over what? 5. Okay? And 2 over 5 is the same thing as what? 0.4 seconds. So my answer to this question is 0.4 seconds. Do we understand? Right. Do we understand, Grace? Secondus? Amojo? If you do, put it down. Let's continue. Tell you come, are you still here? Grace. The range, okay. Let me take it down so I can solve. If you have any question, you can send it to. You can send in your questions if you have. I'll be attending to them. Today is our revision day. We are solving all the problems that we are finding it difficult to solve. All right, Grace, let's dive into your question. This question is under projectile, but I'm just going to explain. All right. Yes, I saw your question, Grace. Onyema Grace, okay. I've done projectile. Maybe I'll send the video to you people this night to watch. I've done projectiles, okay. I've done projectiles and questions on them. So, but let me just solve this one for you. right, so this is the question that Grace brought. So you can send in your questions if you have. Put it down, let's solve together, okay? All right. Onyema Grace. Osage, okay? So put it down, let's solve this question now. It's other projectiles. All right, let's solve. All right, class, the question says, a stone is projected at an angle of 60 degrees, okay? An initial velocity of 20 meters per second. Determine the range. And we are giving G to be 10 meters per second square. All right? Let me go again. A stone is projected at an angle of 60 degrees and the initial velocity of 20 meters per second. Determine what? The range. And we are giving G. All right, so our theta, which is the angle, is given at 60 degrees. Then initial velocity U is equals to 20 meters per second. And we are giving G to be 10 meters per second square. And we are asked to find the range. Okay? If you remember the formula for range under projectiles, because I've done this projectile before, I said that range is equal to what? U square sine 2 theta over G. U square sine 2 theta over G. All right? This 2 theta is something I'm saying 2 times the angle given, right? All right. So let's substitute our value to see what we have. R is equals to, what is my U? My U is what? 20 square, right? Sine 2 times 60 divided by what? 10. And when you have this, let's expand this more and solve. What is 20 square? That is 400. 20 square is something as what? 20 times what? 20. That will give us 400, right? Multiplied by sine 2 theta. That means 2 times 60, okay? And 2 times 60 is 120. So this will be sine 120, okay? Divided by what? 10. Is that okay? Then let's bring it down. R is equals to 400 multiplied by, let's check sine 120. I have 0.866, right? Then divided by what? 10. Okay? So the next thing you are going to do is to multiply and divide, of which that this 0 will cancel 0, right? So we are left with 40 multiplied by 0.8660. Okay? Even though 0 means nothing. All right. So let's multiply. Multiply by 40. And the answer becomes 34.64 meters. Okay, Grace. Onyema Grace, so this is the answer to your question. Let me do it again. We are stating our parameters. Our angle is equal to 60. Initial velocity is equal to 20, okay? Then my G is equal to what? 10. I am asked to find the range. From projectiles, we have proven and we have derived the formula that range R is equals to what? U squared sine 2 theta over what? G, right? Okay, so I'll proceed. What is my U? My U is 20, that is 20 square sine 2 times 60, because my angle is 60 divided by what? 10. Okay, so when you square 20, you're going to get what? 400 is equals times 2 times 60 is what? 120 divided by what? 10. Okay, so we have R is equals to 400 multiplied by, let's find out what is sine 120 is going to give us 0.8660. Okay, now I divide what? By 10. Of course, this 0 can cancel this 0, and I have 40 multiplied by 0.8660, right? And my answer becomes 34.64 meters. Do you understand? So, Grace, this is the answer to your what? Question. All right. All right. Grace, you said, when I press sine 120, I got 0.9. No. Check if your answer is in if your calculator is in degree, okay? Check if your calculator is in degree. Uche to reality, thank you for coming. Good afternoon. How are you today? Thank you for coming. I really appreciate, okay? Omojo, you understand, okay? Now, if you have any question, you can drop it. Let me just solve for you. If you have any question, thank you so much. God bless you for stopping by. Now, if you don't have question, you can copy it, okay? Okay, you understand, okay? Check if your calculator is in degree, because if it's not in degree, you'll be seeing different answers, okay? And it will alter your work. At the end of the day, you're going to fail it. So before you want to use your calculator, always ensure that it is in degree, so you can get the correct answer, okay? All right. So copy what you have on the board. Let's go to our next assignment, okay? If you have question, you can send it in. Let's solve together. All right, copied. Omojo, are you still with us? All right, let's go to the next one. Secondus. Oh, you say you lost connection. Oh, and I've just cleaned the board. Oh, so sorry. Okay, maybe later when I post the video, you can go back to it, okay? So sorry about that. All right, so let's copy this question so we can solve together. Oh, says a grace. Are you done writing? Okay, done. Okay. Okay, already have the question, okay? I'm writing for those that do not have the question. All right, so let's solve together. A meter rule, a uniform meter rule, AB, is balanced on a knife edge, which is 55 centimeters from B. If a mass of 10 grams is hung at P, which is 10 cm from A, calculate the mass of the meter rule. Let me do it again. A uniform meter rule, AB, is balanced on a knife edge, which is 55 cm from what? B. If a mass of 10 grams is hung at P, which is 10 cm from A, calculate the mass of the meter rule. Now, before we can think of solving this, we have to sketch the diagram. It will give us an insight on how to tackle this question. Okay. Now, if we say a uniform meter rule ranges from 0 to 100. Okay. So I'm going to draw. This is what? This is meter rule. And this is A what? B. That means this is 0 and this is what? 100. Do you understand? All right. It is balanced on a knife edge, which is what? 55 cm from what? From B. And if B is 100 centimeter, then 55 cm from 100 centimeter to be placed at where? Just like saying 100 minus 55. Okay? So what do I have? I have 45, right? So I'm going to place the knife edge at where? Here, which is 45 cm mark. I don't know if you understand what I just explained. It is balanced on a knife edge, which is 55 cm from B. So this is 100. 55 cm from this is going to be placed as well, 45. Okay? All right. If a mass of 10 grams is hung at P, what is P? P is 10 cm from what? From A, and A is 0. And here is P. That means P should be kept at what? This is 10 centimeter, okay? Now we hang a mass of what? 10 watts, 10 grams. Do you understand? We are going to hang a mass of 10 grams at what? P. But P is 10 cm from where? A. But my A is what? 0. Okay? Calculate the mass of the meter rule. How do you calculate the mass of the meter rule? Now, we all know and we agree that a meter rule, its balance point is midpoint, okay? The balance point of a meter is its midpoint, and its midpoint is 50, because a meter ranges from 0 to 100. So the half of 100 is what? 50. But I told you we are using the principle of moment to measure what? The mass of object. That is where the question is coming from. Now, how do we measure the mass of this meter rule? We are going to place it at the rightful center of the meter rule, which is what? 50. So I'm going to place it at 50 cm. This is the mass I'm looking for. Do we understand? Now, the distance from this to this, 45 minus 10 is going to give me what? 35. Okay? Now, 50 minus 45 is going to give me what? 5. That's the distance from here to here. Now, this comes in play. Clockwise moment equals what? Anti-clockwise moment. And I told you that clockwise moment goes what? In the clockwise direction. And our clock goes this way. So this is said to be what? Clockwise. Okay? Anything that crosses is no longer what? Clockwise. Okay? So I go this way. This is clockwise moment. Why this is what? Anti-clockwise moment. And moment is the force multiplied by the perpendicular distance. So the force here is m, and the perpendicular distance is what? 5. Is that okay? All right, so let's solve what we have. I will say clockwise moment is equals to m times what? M times what? 5, which will give me 5m, okay? Anti-clockwise moment is what? 10 times what? 35, which will give me what? 350. Do we understand? Now, if clockwise moment is equal to what? Anti-clockwise moment. Now, what do we have? 5m. 5m is equal to what? 350. So divide both sides by the coefficient of m, which is what? 5. Do we understand? And we are left with what? We are left with m. Now it's equals to 350 over what? 5. By the time we divide 5 into itself is 1, 5 into 35 is 7. So my m is equals to 70 what? Gram. So this is the mass of this meter rule. Is that okay? Now let me explain it again. I said a uniform meter rule AB is balanced on a knife edge which is 55 cm from B. If a mass of 10 grams is hung at P, this is 10 cm from A. Calculate the mass of the meter rule. Now, one thing you must note is this. A meter rule ranges from 0 to 100. I believe you have seen meter rule. It ranges from 0 to 100, okay? Now, from here to here is what? My meter rule. Now, the knife edge, which is the pivot or the fulcrum, then it was balanced 55 cm from what? From B, and B is 100. Okay? So if it was balanced 55 cm from B, where are you going to place it? You find the difference by saying what? 100 minus 55, which is going to give me 45 centimeters. So this is where I place the knife edge at 45 centimeters. Okay? Now, if a mass of 10 grams is hung at P, which is 10 cm from A, what is my A? A is 0. Okay? And if I place this mass at the point P, but this point P is still 10 cm from A. So what do I have? Okay, I bring it down. I have 10 watts, 10 grams. So what is the mass of the meter rule? The mass of the meter rule is to be placed at the rightful center of the meter, which is what? 50. Because we all know that the center of the meter rule is its midpoint. Okay? So we're going to place the mass at what? 50. Then we use clockwise moment equals anti-clockwise moment. Do you understand? Okay, so what do? You now say, okay, the difference between this and this is what? 5. That is 50 minus 45. That is what? 5. And the difference between this and this is what? 35. That is 45 minus 10 is what? 35. Is that okay? Then clockwise moment, that is mass times what? The 5, which will give you 5m. Then anti-clockwise, that is 10 times what? 35. It's going to give me 350. Now, from the principle of moments, that if a body is in equilibrium, then the sum of the clockwise moments must be equal to the sum of the anti-clockwise moments. With that being said, we now say, if clockwise moment equals what? Anti-clockwise. What is my clockwise moment? 5m is equals to 350 watts. 350, all right? So we divide both sides by the coefficient of m, which is what? 5. Because we are looking for the value of what? M, which is the mass of the meter rule. By the time we divide, we got our answer to be 70 gram. Is that okay? Right. Yeah, the answer is 70 gram, okay? Secondus. The answer is 70 gram. All right, copy. I believe you understand. All right. Omaja done. Secondus done. Clifford done. All right, so let's go to the next question. All right, so copy, let's solve. Yes, this is under simple harmonic motion, the one we did yesterday. All right. Okay, yes, Grace. I later came and said on the group that we will have class, and I changed the time. Okay, so we had class yesterday under simple harmonic motion, and I even sent the video on the group yesterday, so you can go and look at it. But then let's solve this problem on simple harmonic motion. All right. A student found out from a simple pendulum experiment that 20 oscillations were completed in 38 seconds. A student found out from a simple pendulum experiment that 20 oscillations were completed in 38 seconds. Okay, what is the period and frequency of the oscillation? Now, it's just very simple. What you are going to do is to state the number of oscillation. Number of oscillation. That is what? 20. Okay. Then we have the time, which is 38 seconds. So what do? Again, we get the period. The period is what we are looking for, and we are also looking for what? The frequency. Okay. And you must not forget that the period is the time taken for a particle to make one complete oscillation. That is T over what? N, right? What is my time? My time is what? 38. Okay, divided by my N is what? 20. Okay, so what do I have? I have 38 divided by 20. My answer is 1.9 seconds. All right, so my frequency is equals to number of complete oscillations that a particle makes in 1 second. That is N over what? T. And I told you yesterday that frequency and period, they are inversely proportional to each other. Okay, so I can say this is 1 over T is still going to give me the same answer as what I want to calculate. But I'll try both of them so that you will see. So what's my N? My N is 20 divided by my time is what? 38. So I will say 20 divided by 38. My answer is 0.53 Hz. All right, 0.53 Hz. Now I said that frequency and period, they are inversely proportional. As I've gotten my frequency to the 0.53 Hz, now I can still use inverse of period to still get the same thing as frequency. Okay, so if I want to try it, I will all right, sorry, my network was bad. Okay, let me start explaining all over again. All right, I said I've gotten this frequency to be 0.53 Hz. So I can still use this method by saying frequency is 1 over what? Period, okay? So I will say 1 over, what's my period? 1.9. So let me try that method and see whether I'm still going to get the answer of frequency to 0.53 Hz, right? Okay. So I will say 1 divided by 1.9. And my answer is still equals to 0.53 Hz. So you can see that frequency and period are inversely proportional to each other. So let me explain again. The question says, a student find out from a simple pendulum experiment that 20 oscillations were completed in 38 seconds. What is the period and frequency of the vibration? Now we are given the number of complete oscillations to be 20 and the time for it to complete that oscillation is 38 seconds. Okay, so I'm looking for the period and the what? Frequency. So what we need to do is to state our formula that the period, okay, that is T over what? M. Remember, period is capital T, whereas small t is what? Time. So don't forget. Alright? So my time is 38 and my M is number of complete oscillation, which is what? 20, which is 20, right? Then when I divide, I'm going to get my answer to be 1.9 seconds. Is that okay? Then my frequency is equal to N over what? T. What is my N? That is 20 over what? 38. And my answer becomes 0.53 Hz. But I told you that frequency and period, they are inversely proportional to each other. What do I mean? As I've gotten my period to be 1.9 seconds, so I can still put it here to see when I'm going to get the same thing as what I just did, okay? So I now said frequency is equal to 1 over T. That is 1 over, I've gotten my T already to be 1.9, so I'll say 1 divided by 1.9, and my answer gave me 0.53 Hz. Is that okay? Right. All right, please, do you understand? Do we understand? Secondus, Omojo, Grace, do you understand? All right. Secondus, are you done? All right. Hope you are taking these things down. So I'm going to see it when you come back to school tomorrow. Okay? All right. Let's go to the next question. All right, this is the question I gave. This was the question I gave on the platform, so you can study it down so we can solve. Secondus. Are we done, Grace? Are we done with what we have on the board? Are we done writing? Obi there, sir. Okay, I just come in. All right, the rest, copy what you have on the board. Let's solve together. Okay, let's solve. Okay, let's solve. The diagram below illustrates three forces acting on an object as point Q. The diagram below illustrates three forces acting on an object as point Q. Okay? If the object is in equilibrium, determine the magnitude of the force P. If the object is in equilibrium, determine the magnitude of the force P. Now we are using the principle of triangle of forces, which states that if three forces are in equilibrium, they can be represented in magnitude and direction by three sides of a triangle taken in order. So we are using that principle to solve this. I want you to pay attention, okay? Now look at this force, 10 Newton. It's acting upwards, right? Is it acting upwards? It's acting upwards, okay? So we go this way. This is acting upwards. A force of what? 10 Newton, right? Okay. Down. What again do we have? We have what? From the same point, we have F acting this direction. It's going this direction. It's going this direction, right? So I decide whether I'm putting it here, I'm putting it here. See the same thing. All right? What that will make the difference is this. The direction of this force P. Where is it going? The direction of P is going down. So if I put this force here, this direction can no longer go down, okay? Because I'm going to follow the direction of the motion. Now, if I go this way, this is not the direction of this force P. So this diagram is wrong. You understand? Okay. So let me give you another one. I said earlier that for us to know this is this horizontal force F, for us to know whether it's going to be up or it's going to be down is depending on the nature of this force. Now this force is acting down. So if I place this one here, the force, okay, now the force of P can always do what? Can now come down. and this will now come down. Do you understand? Now we have formed a triangle. Let me explain what I just did. The force of 10 Newton is acting up. I'll draw my vertical force acting up, okay? Then the force of F is acting what? Horizontally. And I said this horizontal force can be here, can also be here. But the position of the horizontal force will depend on the position of this second force. How do we get this? We are looking at the direction, okay? The direction of this force is going this way. So we are going to follow it this way. All right? Okay. So this is my what? This is my P. Now there's something you must know. This force P made an angle of 30 degrees with what? With the vertical. Do you see it? It made an angle of 30 degrees with the vertical. So from here to here I have what? 30 degrees. Do we understand? Then the force of 10 Newton and F have what? Right angle to each other. They're acting as right angle. So I have this here. Do you understand the diagram? Are you sure? All right. Now with that being said, I have to look for the magnitude of P and what? F. Even though I have to find P. So I can as well solve for both of them. What do I do first? The first thing is to do is to get this angle here. Okay? The sum of angle in a triangle is equal to 180 degrees. So let's get this theta here. So it can help us to solve our what? Our question. So we say that 90 plus 30 plus theta is equal to what? 180. That is the sum of angles in a triangle is equal to 180. So 90 plus 30 is going to give me 120 plus theta is equal to what? 180, right? Then I'll carry this 120 to the other side, and I have theta is equal to 180 minus 120, and my answer is equal to 60 degrees. Okay? So this angle here is what? 60 degrees. Then I can solve with sine rule. Is it clear? Right. Okay? So write what you have so we can conclude the question. Do you understand? Do you understand what I just solved? Secondus, Clifford, Omojo, Kamsi. All right. So let's proceed. So we are going to use what? We are going to use sine rule. And sine rule says that what? A over sine A is equals to B over sine B is equals to C over sine angle C. Okay? So going by that, where is my A? I can start with any one. This is what? 10 Newton. The angle facing this 10 Newton is what? 30. Okay? This is P. The angle facing this P is what? 90. This is F. The angle facing this F is what? 60. So let's go. We say this is 100 over sine what? 30. Okay? Is equals to P over sine what? 90 is equals to F over sine 60. Okay? Now I can use this to equate this and also equate this to get the unknown. So the first thing is to get the value of P. So let's go. This is 100 over sine 30 is equals to P over sine what? 90, right? Then I do cross what? Multiply by saying that what? P is equals to 100 sine 90 divided by what? Sine 30, okay? Now, this is 100 times sine 90 is 1, while sine 30 is what? 0.5, okay? Right. Sorry. This is a 10. Okay. All right. So we can go by saying 10 times 1 is equal to 10 divided by this. So my P is 10 over 0.5. So going to give me 20 Newton. So my P is 20 Newton, right? So we can use the same method and solve for F. So by saying that this is 10 over sine 30 is equals to F over sine 60, okay? Now, doing cross multiply, my F is equals to 10 sine 60 divided by sine 30, okay? F is equals to 10 times sine 60 is 0.866 divided by what? 0.5, okay? So I'm going to use our calculator to multiply by saying 10 times 0.866 is equals to 8.66 divided by 0.5. So my answer is 17.32 Newton. So the answer to this question is what? 17.32 Newton. Is that okay? Now, let me explain further. Using this, we are doing sine rule. What is sine rule? Sine rule is A over what? Sine angle A is equals to B over sine angle B is equals to C over sine angle C. Okay? Now, if I start with this one first, the angle facing this side is what? 30, right? So this 10 over sine angle 30 is equals to P over sine angle what? 90 is equals to F over sine angle what? 60, right? And this is what I just have. Now, because this one are complete, is complete, so we can equate this and this by saying 10 over sine 30 is equals to P over sine what? 90, right? Now, we do cross multiply. 10 times sine 90 divided by what? Sine 30. So what do we have? 10 times what? Sine 90 is 1 divided by 0.5. Okay? So what do we have? 10 times 1 is what? 10 divided by 0.5. And my answer is 20 Newton. And for me to get the second force, I'm going to equate this one again with this by saying 10 sine 30 is equals to F sine 60. Okay? Then doing cross multiply, F is equals to 10 sine 60 divided by sine what? Sine 30. And F is equals to 10 times 0.866 divided by 0.5. By the time you multiply and divide, the answer becomes 17.32 Newton. Is that clear? Right. Clifford, do you understand now? If you are just coming, give it a thumbs up and make sure you subscribe to this channel. Are we done? Is that cleared? All right, we are done, okay? All right. Now, I think we are done solving all our assignments. I think so. Grace, are we done solving all our assignments? It's blurring. Secondus, check your network. Grace, are we done? Osagwe, are you done? Are we done solving all the assignments given? Now, if you are done, I want to give you this particular question to try, okay? So after the question, we call it a day. All right, so let me give you this one to try, okay? Let me give you this one to try. All right. Here is the question on the board, okay? So look at it and see if you can attempt it. Right. Clifford, I will see your assignment and everything you wrote when you come back tomorrow. Then you go, ma. You started last week Saturday, so after each class, we used to have assignments. I used to give assignments, okay? So when you watch all the videos, you're going to see the assignments. So I just solved all the assignments today. I can compare your answers. All right, so you have a few minutes to do that. So we can end for today. I will continue next time. All right. Are we solving? Grace, Clifford, Secondus, Omojo, are we solving? Oyema, Grace, are we solving? All right. Clifford, what's your answer? Clifford, what's your answer? You are done. What's your answer? Omojo, write your answer down. Let me see you. Write it down. Let me see your answer. Kamsi, what's your answer? Yes, I'm waiting. Grace, you got 20, okay? Yes, who else is done? 20 what, Grace? Is it 20 Newton? How much are you done? 20 Newton. Okay, so let's try it. All right. Obi, Kamsi, what's your answer? All right, so let me solve. Okay, let's look at the question together. A body P shown in the diagram below is in equilibrium. If the mass of the body is 10 kilograms, calculate the tension T in the string, given that G is equal to 10 meters per second squared. Okay? Now, the first thing we're going to do is to draw the diagram to form a triangle. This body is acting down, right? Okay? And they gave us the mass of the body, which is 10 kilograms. But we are not working with the mass, we are working what? With the what? With the force. Because the mass is a force. So P is equal to what? Mg to get the force. Okay? So that is, my mass is 10 kilograms times 10. So I'm going to get what? 100 Newton. That is this force acting down is what? 100 Newton. So let us draw the diagram. What do I have? Okay. I have this force. I have this force going down. Okay. Then I have what again? This is a force of 100 Newton. Then I have this other force acting this way. Then this one will go this way. That is my what? My F. Okay. Now from the same point, I have another force going this way. So I will go this way. Okay. That is the tension T. Okay. And this T makes an angle of 60 degrees with the vertical. So from here to here, I have 60 degrees. All right. Okay. Then the force of 100 Newton makes an angle of right angle with what? F. So here is what? Right angle. Is that okay? We have formed a triangle. Now the next thing we are going to do is to solve for this angle here, theta. And the sum of angles in the triangle is equal to 180 degrees. So let's solve. It's a 90 plus 60 plus theta is equal to 180, right? Okay. I have 150 plus theta is equal to 180. So theta is 180 minus 150. Theta is equal to 30 degrees. Do you understand? So here is what? 30 degrees. Do you understand? Right. So I can clean and complete the question. Grace, I've seen where you made a mistake. You used 10 instead of 100. That's the only mistake you made. Okay. All right. Are we done writing? Omojo, Clifford, Secondus, Grace. All right. All right. So let's use sine rule. Sine rule. This says that what? What is sine rule? P is a force, Grace. P is a force, okay? Is a force and it's acting down. So that is why we must multiply it by G to get the force. They give us the mass. P is a body, but it's acting down, so it's a force. They give us the mass of what? Of the body, which is 10 kilogram, and the tension, okay? So we need to get the force on that body before we can resolve it. Is it clear now? Grace, is it cleared? All right. Okay, using sine rule, it says that what? A over sine angle A is equal to B over sine angle B is equal to what? C over sine angle what? C. Right? Now let's go. This is my T over sine what? 90, because 90 is facing it. So I have T over sine what? 90 is equal to F over sine angle what? 60. F over sine 60. Then is equal to 100 over sine what? 30. Okay? So I can equate either of them to get the unknown, right? I will equate this and this, okay? So let's go. T over sine 90 is equal to 100 over sine 30, right? Okay, so I will say cross multiply. Cross multiply. T is equal to 100 sine 90 divided by what? Sine 30, right? Okay. Now, T is equal to 100 times, what is sine 90? Sine 90 is what? 1. Divided by what? Sine 30 is 0.5, okay? So by the time you multiply, the answer is going to give you what? 200 Newton. Is that clear? All right. I can still equate this to this to get F. So F over sine 60 is equal to 100 over sine 30. Cross multiply. Cross multiply. F is equal to 100 sine 60 divided by sine 30. Okay? So this is 100 times 0.866 divided by what? 0.5. This is similar to the last question that we solved. So similar. So this is 100 times 0.866 divided by 0.5. Why am I having the same thing? I have 173.2 Newton. Okay? So that is how we can solve this type of question. That if you are given only the mass, you cannot solve with mass. You must multiply by what? By 10 to get the force. Okay? So you can resolve it correctly. Is that okay? Right. All right. Are we all cleared? Okay. We are almost coming to the end of today's class. We're almost coming to the end of this class. Are we done? Omojo, Grace, Obidia, Secondus, are we done? All right, almost. Yes, you can. You can ask your question. What's your question? Yes, Secondus, I'm waiting for your question. Okay, how do you know A and sine A? All right, so let me clean the board and explain it again for you. That is sine rule. Okay, let me clean the board and explain sine rule. Okay. Okay. Now I have this. Okay. This is a triangle. Okay. This is angle A. This is angle B. And this is angle C. Right? This side that is facing angle A is called small letter what? A. Okay. This side that is facing angle B is called small letter what? B. And this side is called small letter what? C. Okay. Then the sine rule says that what? The side divided by the sine of the angle facing it. The side first, this is the side. This is the angle facing that side, okay? The side is A, and the angle facing it is what? Sine A. Is now equals to the side of B and the angle facing it. Is now equals to the side of C and the angle facing it. So that is what? A. The angle facing this A is what? Angle A. I will now say sine angle A is equals to B. The side facing it is what? Angle B. So I will now say B over sine angle B. Right? Then C. The angle facing it is what? C. I will now say C over sine angle what? C. So that is what I mean by A over sine A. Do you understand? So using the knowledge of sine rule to solve the principle of triangle of forces. Is that okay? Do you get it now, Secondus? Right. All right. I think we are done with our explanation. Any other question? Okay, understand now. Okay, that's good. Any other question? In the absence of no question, we call it a day for today. All right. Thank you everyone for staying and sticking to the end of this class. Like I always tell you, the more you solve physics, the more you understand it better, okay? See you next time in my next one. Bye.